Hello, my name is Angela Bauch and I'm from Biomax Informatics, a company located in Munich providing knowledge management solutions. In today's lecture, I will show you how we combine ontologies, semantic modeling, linguistics, and artificial intelligence algorithms to better identify relevant information from the continuously increasing amount of literature. COVID-19 has created an unprecedented global research activity, resulting in 100,000 publications within only a few months. Here this slide shows you the exponential growth of articles published within the first 7 months. And with the start of the pandemic, Biomax decided to make Vilani publicly available for the COVID-19 research community to cope with this avalanche of information. Within Prepare, which is a European Union-funded network to rapidly respond to any severe infectious disease outbreak, we apply a systems approach during the 2016 Zika virus outbreak to generate an integrated information resource. The goal of this approach was to better structure existing pathophysiological knowledge of the Zika virus, and we established a workflow which we further optimize with Vilani at different levels. Here, within this workflow, research objectives were first defined and then a 6-step process was applied. In the first step, an expert team was assembled. In the second step, a data model was designed. Then we applied text mining on PubMed abstracts and full-text articles of Zika virus, imported in a fourth step additional information, experimental data on transcriptomics and intraxomics data, and then visualize the data using queries on the data. And finally, we implemented a web-based user interface to enable experts to review, evaluate, and further refine the integrated information. And here we can see two results of this data, which are the disease maps, which represent an increasingly popular approach to organize, curate, and explore the ever-expanding disease expertise. Here we have a Zika virus map where we have Zika at the center associated with different diseases, here with some host factors, and we have also a color code representing the amount of drugs associated with a gene of interest. This map was, in a second step, further extended and filtered to include potential Zika virus effective drugs, which were then connected to genes associated to Zika virus through protein-protein interaction. And this structured biological knowledge is a valuable tool for downstream computational analysis, such as the generation of predictive models, and opens new avenues in infectious disease research. And all this work has been published last year in Open Biology, and all data and the disease maps are accessible here at zikaknowledgebase.eu. With Vilani, we have developed now an optimized solution where we continuously mine data from multiple literature resources ranging from full-text publisher articles, clinical trials to patents. And this system scales with millions of documents, which provides an AI-based question answering in addition to a conventional keyword search. You can ask Vilani all kinds of questions, such as how to treat schizophrenia, or how does SARS compare to the Middle East respiratory syndrome virus, or what is a BCR-ABL inhibitor, or how to prevent cytokine storms in COVID-19 infections. Then in a second step, you're redirected to the results page, where here in Vilani you have two types. The first one is the keyword results page, which is the document-centric view, where on the left you can further refine your results based on domain-specific refiners, on diseases, compounds or drugs, pathways or pathogens. And here on the right we have the AI answers, which are direct answer to your entered question. And here on top you see these colored breadcrumbs, which allow you to track your search journey, and these are also automatically stored as your search history. What is the background of Vilani? So at the center we have this huge knowledge graph which we maintain since a long time and which is continuously growing. Here on the left by adding structured data or unstructured data, which is text, for instance, from the Medline abstracts, PubMed Central full text articles, news feeds, or lately we also have integrated COVID-19 specific patterns. And these data is then subjected to specialized data detectors and are integrated in this semantic network, which then through tagging and indexing is made available for search. And here we apply two types of algorithms. The first one is a classical NLP query parser, and the second one is a machine learning system. We also have a chemicals perspective of Vilani, where we extract by OCR and OSR compounds, so structure information from text, which we make available also for a chemical search. What are the content sources of Vilani, which you can access here at vilani.ai? We have the full set of Medline abstracts, about 2 million PubMed Central articles, the full set of clinicaltrials.gov, the COVID-19 literature, which was made publicly available from some publishers like Elsevier. We also have the preprint server papers from Medical Archive, bioRxiv, news feeds, and COVID-19 related patterns, which we integrated last summer in a collaboration with Sagacious IP. Moreover, we have integrated about 70 public life science databases and 120 life science ontologies. How does the Vilani knowledge graph look like? It's a network of ontology which are hierarchically built. So here we have, for instance, the protein kinase, which as a child concept has a receptor, and here a non-receptor tyrosine kinase, which in turn have individuals like the PDGF receptor or SARC and LIN, which then in turn are linked to their gene products and so forth. So an Vilani starter knowledge base typically contains 44 million triples. The question answering index now is a combination of semantic networks and neural networks, which we here refer as the Vilani hybrid AI, which combines prior knowledge, so relations contained within the ontology relations, and reasoning and generalization plus neural networks allow for deeper understanding. And artificial intelligence finds yet unknown concepts and contribute to this knowledge graph. The first algorithm which we apply is the NLP question answering, where the first step, the grammatical structure, is first analyzed of the natural language question. In the second step, the entered question is translated into a query against all previously extracted beliefs. And finally, the object of interest is then reported, including the original source. So a triple shown here on the right consists of a subject, an object, and the linking predicate, like here, surname affects osteosarcoma, and here we also have the sentence where it was extracted from. The second algorithm is the AI question answering algorithm, where typically we determine a candidate set of 4 sentences chunks, which is generated in the second step using the semantic tagging index, and where we also use ontologies for contextualization. And from this candidate set of 4 sentences chunk, a neural network extracts direct answers. And based on a machine learning score, the answers are then reported in a ranked order. So with Vilani, we can ask questions like, what are COVID-19 risk factors, as an example here. And on the left, we can refine your answer by using domain-specific refiners from the disease ontology here, and refine your documents which you have identified, explore your answer within the network, or obtain direct answer to your questions like hypertension. So in conclusion, Vilani supports the research community with a tool combining literature mining and an AI-based question answering system. You can keep track of the increasing amount of literature and remain up to date, assist researchers to find information faster, identify relevant content. And lately, we also contributed to a large-scale community effort to build an open-access, computable repository of COVID-19 molecular mechanism, the COVID-19 disease map, which we submitted 2 weeks ago to bioRxiv. Thank you for your attention.